Hi everyone, in this video we're going to be looking at the Pythagorean Theorem and how we can find missing lengths of specifically right triangles. Now the Pythagorean Theorem is used with right triangles, and how it works is that if you actually take a side length of each side length of this right triangle, what you're doing is you're finding the square when you square 3, when you square 4, and you square 5 in this formula, a squared plus b squared equals c squared. Really what that's saying is that I could take this side length of 3, and if I were to actually create a square, I know that looks like a rectangle, right? If I were to actually create a square with 3 boxes here, and I would just take another square with a length of 4 units. You can see here that there is 9 boxes, and in this one there's going to be 16 boxes. In this next one, if I were to draw this square with a side length of 5, and I'm going to do it this way too. 1, 2. Again, not to scale. But there would be 9 units here, 16 units here, and 9 plus 16 does equal the 25 units on this side. So Pythagorean theorem is saying if I take this one leg squared, which is 9, and I add it to this one leg squared, which is 16, it should equal the third side length squared, which 5 squared is actually 25. So in my example, 3 squared plus 4 squared equals 5 squared. 9 plus 16 does equal 25. So let's look at a problem. If I'm given a triangle, a right triangle, and I know the side lengths are 20 and 21, and I'm trying to find the hypotenuse, the C. That means I'm going to take my 20 and 21 and substitute them in for A and B. Now, it's okay if you say this 20 is A and this is B, 21 is B, or vice versa, as long as the hypotenuse is always C. This one always has to be the hypotenuse, no matter what. So when I put that into a calculator, I get 21 squared, which is 441, and 20 squared, which is 400. Add them together. And then I'm going to take the square root of both those numbers. When you take the square root of 841, you get 29. A great way just to quickly check is that since this has to be the hypotenuse, the largest side of a right triangle, this number has to be larger than 20 and 21. So remember, the hypotenuse, the C value in the Pythagorean theorem, is always across from the right angle. Let's look at another example. Before I actually move on to that other example, these obviously I can't click, but if you're following along on the guided notes that have been shared, if you click these will give you some other helpful videos as well. Alright, let's take a look at an example. Solving for a missing leg. Well, first I have to write which parts are which. This will be a leg. This would be a leg. This one here, the 20, is our hypotenuse, so that will be C. So if another way to write this would be C equals 20, this would be A, and that one would be B. So 8 squared plus x squared equals 20 squared, making sure that that 20 is the hypotenuse, C. So 8 squared, 8 times 8 is 64, plus x squared is equal to 20 squared, which is 400. I'm going to subtract 64 from both sides. I get x squared equals 336. And then I'm going to take the square root to get x by itself, or the missing leg. And I get about 18.3. 18.3 units. You're going to need a calculator for this. I did not do that in my head. So, I generally know that's correct because it has to be less than our hypotenuse. Remember, this number has to be the largest side length. Just a real quick way of checking this is if I put this number back into my Pythagorean theorem, back into this formula, 8 squared plus 18.3 squared is going to be really close to 20 squared, or 400. It may not be exact because I did round this number, but it'll be very, very close.